Hey, everybody, greetings, good morning, good afternoon, good evening, wherever you are in the world right now. Welcome to another episode of Code Rush. Roy, are you on the line with us?
I am on the line, my friend. I am ready to rock, as they say.
How are we doing over there in jolly old England?
Jolly old England is cold.
Cold?
And yeah, it's just, we're at that point of the year where the weather's deciding just to descend. Contrary to some people's belief, it's not a disaster year round. It's actually quite nice, quite frequently. But at the moment, it's cold and it's dark. Luckily, we're heading for sort of more jolly times. Christmas and the like is on the horizon. I gather you guys got Thanksgiving coming up.
Yeah, hold on a second. I'm getting that Rory is really low. Let me adjust the volume on that. Rory, can you talk to me a little bit?
Testing, testing, one, two, three. Is this any better, Will?
Let me throw my
Am I
desktop audio
easier to
just a
hear
little bit.
now?
Thank you so much. Yep, you know what?
Hopefully.
Yeah, here, let me share this so people can see what's going on. I think this impacts Rory's volume. And go ahead and talk
Ooh.
now. I bet that's louder now, isn't it?
Yeah. Is that a little better? It was
And
only a little previously, but that was any better now, Will?
only
Things
a,
improving steadily, hopefully.
yes,
A
he
little bit
says yes.
positive.
Okay.
Yeah, there we go.
Yeah, okay. The problem is that it's blasting in my ears right now. I wonder what happens. Yeah,
Yeah.
the problem is I can't do this. I need a separate volume control. I'm gonna have to get a separate mixer here. This is one of the things we've been talking about. I've been talking about getting a better mixer control over all the audio here. I'm going to assume that this is okay,
Hmm.
and Rory's just not going to blast out my ears too much.
I'll try not to shout.
Thank you. Let's see. Oh man, oh man, oh man. I am without CodeRushed today because I have a special build. I'm was doing some testing, and didn't do the latest install, and I don't think I can get around that without stopping the stream.
Oh no.
So it's going to be a little. We're going to just go from
It's
scratch
going to be
here.
tough,
Yeah,
but you know.
we're going to do that. Will's asking, do you have a cold, Rory? Under the weather?
A little bit. Is that coming across so obviously? Oh dear.
Yeah, just a little. It's a little bit there. So yeah, Rory's got a little bit of that. I'm not. I feel like I've been just bullied with unexpected surprises this morning. I've got two stream decks set up here. I think I can lift one of them up here so that you can so that you can get it in the camera. Actually, let me do this. I'll switch over to my keyboard camera and point. Here's one of them right here, and this has got all the different things on it for all the different things I want to say. I've got about 200 of these combinations in here. I know it's hard to see
Wow.
it's hard to see the buttons on here, but each button has got a. I might be able to. I don't know. Not sure if I can quite get it, but I'm trying to get it so that you can actually see the content on the buttons. The problem is there's enough light on the room, and the
No, I
contrast
can
isn't
make
showing
out
up.
that there is some text certainly,
Yeah.
but what it is, not so sure.
So anyway, I've got about access to 200 of these. Like if there's a bug, I can hit the bug button right here, and then I can come and say, "That's a bug."
That's a bug.
And similarly, folks in the chat room have access to these as well. The problem is that I was over the weekend. I was prepping for a brand new show that I'm going to do. That's going to be a comedy show. If you've seen or you're familiar with my previous work on Mondays, the podcast Mondays,
Oh, yes.
it's going to be crazy like that, but live on Twitch, and we're going to essentially be playing Dungeons and Dragons. That's the essence of it. And so I'm setting up for that show over the weekend. And then when I came up this morning, I noticed on my stream deck, every single one of my 200 plus combinations had switched to scene. All the data was lost on it. They were all not working. I had to rebind, and it's a mess, rebinding. Let me show you that, because sometimes we talk about good design on this show. So, whoops, hold on. I totally grabbed the wrong thing here. This is what I want to grab right here. So these are the pieces that were lost right down here. If I switch over to my left deck here, you can see some of the mess here. So here's my off-rails one. It's connected to VS alignment. And if I click the off-rails button on my deck, back up here. So there's some of this that's working, but everything is on the wrong one right here. So in order to select it, I've got to come in here and now find off rails. But these are listed in chronological order in which they were created, not in alphabetical order. So if you're looking
Which would, be so much simpler if they were.
Or if there was a filtering or some kind of easy way to bind these. Notice as I get more and more, it gets harder and harder. The problem gets more and more painful. So I've got to go search through here, find off rails, and rebind it. I've got to do that about this many times for all of these that are here. So
any idea where it saves that data, whether that list is actually on disk?
Well, they support exporting, but I did export and I tried re-importing, and they were all destroyed again. So
oh dear.
I am going to have to export again. Be incredibly careful about this whole thing. I really am nervous about what happened and the amount of work required to bring it back. So anyway, I was hit with that. Just now realized that I don't have CodeRushed installed. Shoot, that's going to make things harder to code. Plus, Rory, when you weren't with us last Thursday, I had a tough time. I was like trying to solve a problem, and the code looked right, and yet the behavior was wrong. And we're going to hit that same problem again today. So
okay.
So that's go ahead.
Let's see what we can do, I guess.
Yeah. Wait. Rule Bennett says all departments need that button. That was the button that I think we were on the off rails, I think, or something like that. Maybe. I think that's what he was talking about. All right. So with that, let me show you the problem. And that's a bug. That's a bug button. Got it. Thanks, Will.
Yeah.
For that. Okay, makes more sense. So let's look at the problem here. Let's run. We're going to start by running this. We'll get the overlay bot up and loaded too, because right now it doesn't look like it's up yet. And what's happening? We're building. You can see the build icon right over there.
Mm-hmm.
Right over there. And the problem is essentially, the problem I was trying to solve, and this is one of those things that happens in programming sometimes, Rory, where you're like, okay, I have a hard problem to solve. I run the test code, and it works. And I'm like, oh, that's cool. And then I start stressing it.
Yep.
Right? I like say, let's check it on planet Pluto, right? Let's check it from a different distance. And it starts to fail. In fact, we discovered the lower the gravity and the farther the distance, the greater the amount of failure is basically what we discovered.
Okay.
Let me set this up right here like this.
Cumulatively building error.
Yeah, that's kind of it. So let's come in here. Let's see if I can remember all of the pieces, because it's been since Thursday since I looked at this. I think it's test sample 4 is what gets me going. That didn't work. Does a launch work?
Is Mr. Announcer Bot even? I guess he must be if you've got the launch and so forth.
The launch just worked. Let's try seed. Seed works. Maybe
Did you rename the functions for the samples at any stage?
Maybe it's not sample 4. Let's go look at it. It's entirely possible I'm remembering something else. Test sample 4 should start game sample 4. Did I not type that in right? Maybe let's try it one more time. Maybe it's possible that it wasn't entirely loaded. And let's go back over here. It was not loaded. That was the thing, Rory. Okay, so it wasn't entirely loaded. Okay, so test sample 4 is correct. Bring out the drone. Let's just fly to the right 4 seconds, and this should work. Notice it's giving me a predicted point of impact right there.
Yep.
Okay, that's one of the things we wrote as well, which is actually really cool from a debugging standpoint. Let's get out of here. Let's toss this.
It lets you know before you get there what the estimation of the system, is regarding your needs, and the fact that it is planning to pass something out. So that's good. Yeah,
from the standpoint of if you could make the argument that I wasn't making a lot of good decisions on Thursday, and partially because I was a little bit tired too. This thing where it shows where the crossover point was one of my best decisions right there.
Yeah.
So this was my first set of tests, and I was like, how exciting is this that this is working, right?
Yeah, it's nice.
Then I was like, let's try Pluto. And
So Pluto is less gravity?
Yeah, a lot
Quite
less.
Significantly less.
And I'm going to just throw that away. I'm going to drop down a bunch. And I'm going to go actually to the right and go down again. And, this is not as far as I want to be. Okay, now, what's interesting is now I'm not even seeing it at all show up, but it should totally be here. Let me go right again. Oh, there, interesting. Look at that. Looks like it's even worse over here. Okay, there we go.
Okay.
Hold on. It looks like we got a separate bug. I'm more interested in the bug I'm about to show you, which is right here. Is that it crosses like well before it says it's going to cross, and that's the thing I'm not so sure about. Let me go left.
So
3.
keeping as many things static as possible. If you start on the left now with this gravity for the first time, that is definitely.
Hold on a second.
Providing a value.
Let me go down a little bit more. I want to go to the very bottom, and then I just want to. So it's that right there is from the previous one when I was heading there, and so what I want to do is I want to head there now, and I want to so I'm going to say
each time you start moving towards it, it effectively cues
right.
another meteor, even if you then decide to go in a new direction.
Yeah,
and that countdown continues.
So I'm going to hit right 7 right now, and that's going to move me right for 7 seconds with the thrusters on for 7 seconds. So let's watch what happens. It's adjusted, and it says 5 seconds, but I crossed there in like 3. In other words,
you did.
The time I'm calculating to cross is way off as we get further away from the portal and gravity is more into consideration, which indicates that it's probably, this could be as simple as a math error somewhere.
The calculation is just using the gravity of your, well, it's not using the new gravity. So it's suggesting it should be happening a lot earlier than it actually is. Sorry, it was the other way around.
Well, it's as if it is throwing the drop time into it, is what I think it is. I think that might be. I was thinking about it this morning, and I was saying, this be that it's just adding a number to it that it shouldn't be adding? And so here's what happens. This is the code that we're kind of dealing with here. We're calling Q meteor. We have a future drop time right here that we're passing in. We subtract from that the amount of time that comes right here to be able to drop, whatever that drop time is going to be. I think I want to do this. I want to put a console log out here for this. Guess what? I don't have CodeRushed, so I can't use my templates. So I'm going to type it in by hand. This rarely happens to me that I have a day without CodeRushed, but I was testing new functionality that only installed in a different version of Visual Studio, not this, and that's why I lost it. And I can't show you that other version of Visual Studio until a certain embargo date is done, and that's all I can say, and there's nothing else I can reveal.
So there's just this good stuff coming, but we can't tell you what.
It could be an older version of Visual Studio too, I suppose. That's also a possibility. I'm revealing nothing at this point, but other than I don't have CodeRushed. All right, so we're going to throw our drop time out here when we calculate that and see if that helps us at all. I'm going to refresh out over here.
Okay, so just to remind everybody what should be happening is as you start to move towards the portal, it calculates when you're going to cross the portal. And the idea is that it would spit out a meteor at such a time so as the time taken to drop meets you as you cross the vertical.
Yeah, that's exactly it. So let's do that. Let's change to Pluto.
But of course, that's based on the drop time that will be derived from the current gravity.
Right, exactly. So I've changed to Pluto. You can't see it because I forgot to launch, but
it's okay. We see it in the chat there anyway.
Oh, is it in the? It's in the. Yeah, you can see that I've typed it in the chat. Let's go bring up the console because I want to be able to see that, and then let's do the same. And there you can see just the edge of Pluto. There's Pluto.
Sure.
So now let's move to the right by 7 again, and let's just see what happens. What we pass out there into this. And so the drop time, we can see that. Let's just scroll back and look at the drop time here as we go up. I kind of want to see the first one as it showed up. The drop time in milliseconds is about 7 seconds. So from here to where we're going to cross, it's 7 seconds all the way across the board.
Okay.
So, all right, so that's good. I'm happy with the drop time.
Is it even conceivable that the meteor can drop that distance in time to meet you going through it? Because it only takes you maybe 3.5 seconds to get across that line.
Right. Well, hold on a second. Let's see. The future drop time is a time point in milliseconds, I believe. It's an actual offset, and so the future drop time is going to be whatever that. So here we'll look at this. See this time milliseconds? That's part of future point right here. And that's inside of get future point. If we drill,
so we first calculate what the future point is, i.e., where you will pass.
Yeah, that's equal to now
geographical location.
Now plus seconds to cross over times 1,000. Okay, so that is going to be an absolute time offset from the now passed in to get future point. Okay.
So what I'm curious about is, let's say that calculates that you are going to cross the vertical in exactly 4 seconds based on all the available data.
Right.
But that it would take more than 4 seconds
right.
to drop.
Right. So what happens is
it's not even possible to achieve what we need.
Right. But watch this. Future drop time. If future drop time is greater than now, then we go ahead and cue the meteor. Okay. We also will remove it if the future drop time minus now is more than 10 seconds. We'll remove the meteor. So we added that code as well, because what was happening is we had a whole bunch of meters dropping down. So we're only queuing if it's positive. We're only queuing the meter in up if it's positive. And the call to queue meteor checks to see if there's an existing meteor by that name and removes it. Okay. Right? So in fact, we should probably it's essentially a call to remove meteor. Is essentially what it is, with the exception that this does a break as soon as it finds it, whereas this continues through the whole list, looking for a whole bunch of them. But arguably, we could replace this with remove meteor, and it would be no different. This dot remove meteor user ID, like that. And that would be functionally no different, because we are never going to have more than that. Oops, Control K C, there we go. And meteor drop dot owner. Oh wait, owner, meter drop dot owner is the user ID in this case, like that. So that's the same as that. So this is what I'm talking about, right, Roy? Is I have code that appears to be reasonable and good, right? I'm coming in here, checking out that drop time. I'm getting the future drop time minus the time it takes to drop it to reach that point. And so look at this, and we'll back it up in here. Here we're calling get drop time, which is inside of physics, and it's calling pixels to meters, distance to drop, gravity games. The thing that seems odd about this whole thing, hold on. Will Bennett says, even just eyeballing, I'll still say it's unsolvable. The drop time calculation may be wrong, but regardless, due to gravity, there's enough time to catch. The portal doesn't control the rate of fall. Am I missing something? No, you're right, Will. You're right, but that's why this line of code on line 80 is here, right? We're basically checking to see if what it would take to drop this, because we're taking our future drop time, what it would take to our future cross point time, and we're subtracting the drop time from it. And if that future drop time is less than now, then that means we can't drop it, and we don't do anything. We just forget about it. Okay, but if it is
less than now, so if you start on the left with a journey time of 4 seconds to the point in question, then what you need is to calculate a future drop time, which is
4 seconds from now.
That same length of time.
4 seconds from now, right?
So the future drop time will be 4 seconds from now. That is greater than now, and therefore you will drop. But if the future drop time, let's say it takes 6 seconds to fall because of gravity,
then this will be false.
Then that should be,
because the future drop time
in the past.
Yes, the future drop time will be future drop time will be 2 seconds ago. And then we'll say, oh, sorry, we can't do that. In other words, the word future there, maybe I should just change that to drop time instead of future to make that a little easier to read. So let's do that. So let's come in here and we'll call this drop time. So we're not, really use camel case navigation all the time. Okay, so that's gone. And guess what else is gone? Tabbed index reference is gone.
Yeah, that's the killer.
It's a tough.
That one
It's
there.
It's a tough day. Okay. All right. So let's see. Drop time. So there's my drop time. Let's go look in the Q meteor. See what's going on here. Just to double check it. Meteor drop. We're going to push the meteor out. Meteors to drop. Tabbed index reference is gone. Still. Let's go look at this. Yeah, tabbed index reference is a great feature that I rarely think about, except for now that it's gone. So now I'm just doing a search here, and I'm hitting F3 to repeat my location here. So future point is this. We draw crosshairs on the future point. So this is something new that we're doing right here for diagnostics. So that's the crosshairs. We're putting the actual time. So we're saying future point dot time ms minus now.
So maybe we need a few base facts, such as at a specific height, a specific distance from the portal in terms of height, how long should it take for the meteor to drop?
That is actually, we're seeing that. In fact, if you watch this crossover, that cross that's there is going to show you a countdown exactly to when the meteor goes under here. In other words...
so the max value, the very first value we see, is effectively that initial quantity of time.
Yeah.
And then it updates it as the meteor starts to fall.
Yeah, so if I go right here, let me do one other thing for a second here, because I can start up Mr. Announcer Bot here. It doesn't look like he started, and now I'm just starting him up so that we've got Mr. Announcer Bot kicked in. It looks like authentication failed, though. I got an error. This could have something to do with upgrading OBS. All right, so let's do this. I'm going to move right by 6 and watch the countdown. It's 7, 6, 5, 4, 3, 2, 1, 0. Boom, and it crosses it.
Right.
So but
it was very clearly not 7 seconds until you crossed.
Right,
that
exactly.
Was the length of time it took to get there.
Yeah,
absolutely. Which means, actually, now if you repeat that experiment, and we see if we can observe the length of time between when you actually start to move. So I guess when you hit enter, and when that shows up on screen. Because if it is immediate, then there's definitely something wrong with that calculation, because it should have been saying, no, this is in the past. It cannot fall long enough, or cannot fall quick enough.
Yeah, I think you're right. Because that was easily a 5-second kind of thing, and it takes That
was starting to go back up again. Well, that was because of second calculation as you approach.
I think that's what's happening. Yeah, it's coming back. Here, let's go left 3 here a second. We'll watch it one more time. 6 seconds. It takes 6 seconds to drop. But it clearly only takes 2 seconds to get there. So we've got the drop time of 7 seconds. Maybe the other piece we need to talk about is, here it is right here. Look at this, seconds to crossover. If we look right here over my shoulder, let's see if I can zoom into that. There we go. And so we've got seconds to cross over, very little time, and yet a drop time of 7 seconds. So somewhere our math is wrong.
Yeah.
Right? So let's look at where we've got seconds to crossover in the code, where that piece is coming out here. Seconds to crossover, not here. Let's go over into drone, I think. It's right here. Here's where it's coming out, right here, I think. Let's just double check that. Yeah, because it's wrapped onto a second line. So seconds to crossover. I just realized we can do, what was it? To fixed and number of digits. Let's just do 2, like this. So we've got this, can get this all on one line right here. So seconds to crossover is here, and seconds to crossover is pretty low. And we're coming in here and saying now plus seconds to crossover times 1,000. So that future point, these are in milliseconds, that distance should be good. The future point. Get future.
So Will suggest in the chat room, I think you should be comparing drop time with seconds to crossover, not now.
Let's see if I can see that. I think we're talking back over here.
That's the if drop time greater than seconds to crossover, then you shouldn't drop.
Drop time is...
Right, so drop time, is that a relative time? Or
that's
is it,
absolute.
That's a good question. Is it,
Yeah, that's absolute. Let's look at this. Look at this. Let's call this absolute. Let's just double check this and make sure. Let's go find this everywhere and look at that.
so absolute time is an actual point in time or a quantity of time?
I'm going to call it an absolute point in time, but I'm not seeing where it's assigned. I just did a search for all of this. Oh, it's assigned in the constructor for the constructor. It's in drone, but it's for future point. So when future point is constructed, it's an absolute time in milliseconds. Let's double check that and make sure that's absolutely the case.
Well, immediately above, you can see now plus seconds to crossover times 1,000. So it is a point in time.
Yeah. So
it's a future point in time, which is kind of what we'd expect.
And we have two options of that, now or now plus seconds to crossover. So that is an absolute time in milliseconds right there. So let's go back over here. Absolute time in milliseconds.
So then if we take away some milliseconds from that, we will still have an absolute point in time, which is comparable with an absolute point in time.
Yes.
I.e. now.
Right, exactly.
Now, if we take an absolute point in time from another one, we then have an absolute duration, a fixed duration of time, which is comparable with the 10,000, which, again, seems to be fairly accurate.
Right. The code looks right. Ah! Yeah. This is like, I feel like I just need just a little more brain power. And I'd be like, duh, like this, and know exactly where the problem is. But I don't see it. My gut feel on Thursday was the problem was that, well, hold on one second here. In get future point, I think is where we were. Had that other console information that was coming out. And we look over here at the data. We were showing a seconds to crossover of 0.02. Okay?
Okay.
So the seconds to crossover here is, and the seconds to crossover getting modified in any place here. It looks like it's not. Okay. So I just want to make sure that was happening. So we create the future point. If seconds to crossover is there, right, then we should be able to, as soon as we come back and get our future point, we should be able to double check that. It's as if this is kind of changing, is what it seems like. The thing that's happening is that it seems like it's changing a little bit. Let's go back to Portal and see when we get this. So here's where we get it. So now, and we pass in the same now to it as well, right? So at this point, we should be able to verify seconds to crossover here. And let's take a look at this. Absolute drop time. Oh, wait a second, though. I think we need to, I think Will may be onto something here. What if we said, there's the seconds to crossover. Hold on a second. Get the drop time. So the future point, all right, let's do this. Let seconds to crossover equal now minus future point dot absolute time ms, like that. And seconds to crossover. And then let's do a console log of that as well. So drop time milliseconds, let's do it to fixed here as well. Give it 2. And Will Bennett saying backwards. I get that backwards. You're right.
Well, if you subtract
I did.
The future from now, you'll get a negative value.
That's right. Good job. And plus seconds to crossover.
So it's an interesting comparison. We could take the seconds to crossover and could say, well, if it's greater than 0, then it's some point in the future and we're good to go. If on the other hand it's negative, it's not possible to intercept.
Is that
To be
true?
honest, it's probably just another way of saying the same thing. Unfortunately,
No.
Really kind of covering that.
No, if it's comparison of seconds crossover versus drop time is kind of what's going on
Sorry,
there.
yes.
So we can say we can do if seconds to crossover. Oh my God! Also, the if template is a big time saver as well because it adds those parens for me. Okay. Okay. So if seconds to crossover is or if drop time is greater than seconds to crossover, then we can't do anything and we're out. And what are we in? We're just a single. It's in a single. All drones is a sprite collection. I'm looking for a 4 each in here. Oh my God. What are we doing with all drones? I wonder if we're doing, hold on a second. Oh, it's down here. I see. Okay. I see. And this is check drone here and we're going down there. I gotcha. So if I do it, I should be able to do a return here since I'm inside a Lambda, and it'll keep going and checking all the others. That's my assumption. Well, then it says you're going to need to see the doctor after this stream, suffering from CodeRushed withdrawal. Yeah, exactly. And I think I had just enough time to redo those, to get those keys done on my my Stream Deck. Okay. And let's throw a console.log out here as well. Console log, not enough time to drop. Like that.
Yeah.
And so we'll send that out. And the other thing we might want to do is throw out, let's put these first. Let's try that.
So we have discovery of the facts, we have putting them out there, and then we have a deduction that because one is in excess of the other, we cannot get anything done.
Yeah.
Now, in fairness, we're still doing the same code underneath as we were before.
Question, is that comparing milliseconds to seconds? It absolutely is.
Oh, good catch.
Times 1,000. Nope, divided by 1,000. Okay. Yeah, I'm going to change this just a little bit. Drop times. I'm going to create, just for diagnostic purposes, I'm going to do seconds. Like that. That's equal to drop time milliseconds divided by 1,000. Then I'm going to come in here, and then I'm comparing the two. Good catch, Will Bennett. I totally appreciate that. Will Bennett. Also, check it out. That's one of the other buttons I prioritized because I thought we were going to see that. I haven't been able to reset all the 200. I've only been able to do a few of them. So there's my drop times to seconds, and then we're going to say drop times to seconds here. Not enough time to drop. We're expecting to see that at least.
So your previous call to remove Meteor, which was happening on the strength that you didn't, not only did you not have enough time. No, that's not quite true, is it?
I removed the meter.
To see how the lines 87 through 92 are going to follow through. Certainly, we need to queue a meteor at the right time, but are we removing one, or are we failing to remove one because there's not enough time to drop?
That's a good idea. That's a really good point. Let's remove all the meters from right there. I think it's a good suggestion. Right? That's what you're talking about, right, Rory? That line of code 84?
I was merely, because what we've got here is some new diagnostic code, which is going to inform us in the console that there is not enough time to drop, and stop proceeding through the rest of it. So at that point, you are not going to queue another meteor, which is correct, but you're equally not going to remove any meteor, and perhaps you should have. So yes, by putting that there, that is entirely plausible.
Yeah, so let's do that. All right, so let's do that. I feel like we're getting closer. At least we're getting better diagnostics. Let's refresh.
Do get down to 93 though, will that cause a problem if no, because we'll have returned out. That's fine. We'll already have quit from that by then.
Okay, so we're back over here. Let's do test sample.
Yep.
like that. Oops, sorry, that's the wrong one. Test sample 4. There it is. Let's launch so we can see the planet. Switch to Pluto. Drop my drone. Go down 3 seconds. And move over. I'm going to wait till the console's kind of going a little crazy here. I think it's because I'm still moving. I was just going to wait for it to stop, like it's just stopped there. Let's come over here. Let's clear the console. And let's now queue up the command write for 7 seconds. And it's going to cross like right behind me here. Do I want to do this? Let me do this. And then so we can see that there. So it's going to go right there is where it's going to cross, right about there. And so here we go. I'm going to move it and let's watch it and see what happens. So we still have the same problem, but let's see if we have better data here is what I'm looking for. And let's scroll up here.
Okay.
I want to see the first kind of, so notice we've got 7 here all the way. I just want to see the first thing because all the way from the beginning. Okay, that's good. So we really aren't, the drop time, the meters to cross, the meters to cross over is 15.37. You can see it's changing as we move forward.
It is changing ever so slightly as we go down. Obviously, there's a lot of statements, so that will accrue over time. That's
My
good.
velocity also, look at the seconds to crossover. Seconds to crossover is huge here. It's wrong.
That's a little high, eh?
It's wrong in the second time I get it. Do you see that? That's like
That's
this.
amazing, yeah.
I don't get that.
So that's in the second. This is from your portal TS, as opposed to the drone.
Let's see. This is inside of, I think, drone actually is what I think it is.
Drone had the smaller value and was outputting.
Yeah, it's not. This is misnamed. See, it says seconds to crossover right there. Hold on. This is the problem. Oh my God, I think I've found it. This is the problem. It's called seconds to crossover. It's not. We multiply it by 1,000 here, but we multiply by velocity. That's got to be seconds here. So what we have to do is we have to say 1,000 times. Wait. Hold on. Meters divided by velocity. This is going to be in fact seconds to crossover, which means this future point should not be times 1,000. To be honest, that line of code right there, we might have added that late Thursday when we were playing with different ideas.
If seconds to crossover is seconds and we add it to now without multiplying by 1,000, isn't now registered in milliseconds?
Hold on. Yes, now is in milliseconds.
So your corrected code will add seconds.
Oh, you're right. You're right. Hold on. So this is not. Wait. That's seconds to crossover. Yeah, no, you're right. That is correct. The corrected code is good. Okay, hold on.
So
wow.
Y at crossover equals meters to pixels, which is velocity, which is meters per second, times seconds, which is still seconds at that stage.
Yeah, so take a look at this. I'm taking now minus the time start. That's going to be in milliseconds, dividing by 1,000, then we're in seconds. So if I pass anything to get final velocity, it's going to be in meters per second, is what it's going to be. It's going to come back
we have
in.
Seconds passed, we have velocity X, velocity Y, that's all good.
Meters to crossover, excellent. Seconds to crossover. Then I go meters to pixels to convert back. So and I'm doing pixels to meters here as well. So and let's just delta X in pixels.
Delta X is definitely a pixel related thing. That's good.
So we've got that. And meters to crossover, seconds to crossover. Okay, never mind. I was like really excited for a second because I thought I found something, but it's not here. So the problem isn't here.
For a second, Mark, to your copy of Chrome, I thought it was not the drone version of this that was huge. It was in fact the portal version that was huge.
You're right, it is. So you're absolutely right. So let's look at that. Seconds to crossover is because this is not right. Is the problem here? Let's rename it.
That's a milliseconds to crossover.
Yeah, exactly. Okay, so we need to now change that. So there's my problem with the code. So it's going to be this divided by 1,000 And that's going to be our seconds to crossover. So our code wasn't quite right, the diagnostics code we added. And, okay.
Now, all of that said, if we have now fixed this by a factor of 1,000, those values were still very high, 1,600 seconds.
Well, but we had not quite accelerated. We'd not quite got our velocity up yet, and it was changing.
Okay.
So let's look at that closely as we come down here. So we'll come in, say test sample 4, and there it is. Do a drone, do launch, change to Pluto, go down 4. Whoops, that was maybe too far down. It'll bounce up. Down 3 is what I should have done. Let's go down 1 like that. And then we're going to say R7 like this. And let's clear this before we go. And here comes the R7, and let's watch it. So you can see, there we go. All right. Not enough time to drop all the way across the board now on here. Is interesting.
Yeah.
So we didn't drop
The
at all.
values themselves seem much more reasonable now, which is good.
Let's watch the acceleration on these as we're going through here. So seconds to crossover, watch it drop down. We want to watch to see where it kind of evens out. And it's right around this point right here. And our velocity x is about 1.3. We're up to 1.6 here. So at 1.6, 1.7, we have seconds to cross over is at 10 and drop time is 6.61. That's enough time to drop is what it is. So we're now pushing the meter to drop in 4 seconds.
The crossover is our time, when we're going to cross the y-axis. Yeah?
Yes, but wait.
The point on x.
Let's see what happens with that. That seconds to cross over seems wrong all the way. Although my velocity gets all the way up to 7 here. So it takes a while to speed up here. I think what happens is, and then we get to not enough time to drop. I think there's a command. Let's see here. Change velocity on this. CV. Did I delete that? I think I may have also deleted that. So let's look and see if we can find that too. Do I have that open? No, I do not.
So from the time we did have a meteor dropping, I seem to remember the value being displayed when it was ejecting said meteor being somewhere between 10 and 7 seconds for the actual length of time to fall, or at least the prediction was. So if that's accurate, we need to predict that unless it was going to take you that amount of time, it would be reasonable that it says actually there isn't time enough for that to happen.
So are we basically saying, so here's the question. I'm going to do this. I'm going to reinstate a command here called CV. I've got it commented out here, but I'm going to put it in here. And so I'm going to basically come in here and say, look, if params is equal to CV, can I do that? No. You know what I'm going to do instead? I'm just going to do this. I'm going to close this down. I'm going to do a little bit harder way to do this, but I'm going to shut this down right here. I am going to kill all instances of Chrome, which I've done. And now that I've shut it down, I'm going to comment out in background worker the ability to change drone velocity. And what this will allow me to do is instantly change the drone velocity. Mm-hmm. Okay? And once I can do that, because then we can look at this, because maybe my new theory is, what if the reason the code looks right is because the code is essentially right, with the exception of the deciding whether to drop or not. It looks like that is wrong because we didn't drop at all this time, right? And so the idea is this:
Sure.
With an accelerating drone, right, the crossover time is changing, right? And as I start, the crossover time is further away in the future. But then all of a sudden I accelerate past it, and now we can't drop because it's too late. But it could also be, wait, this could also be because of, actually it is this code. It's this code right here that removes the meteor, right? Not enough time to drop. I don't think necessarily we should remove the meteor. No, because it's going to miss it. Yeah, I think what's happening is we're missing it. I think the code may be right, and we're just missing because we're accelerating. And the test.
So you start with a point where you're just never going to cross it in time for it to ever happen, and then because your acceleration is increasing, suddenly you're going so fast that there's no hope of getting a meteor there.
Right, no hope of getting there in time. That's the idea. Is that there's a transition.
Skip over that kind of Goldilocks path.
Yeah, that's kind of what my new theory is, which is why it works on higher gravities, but not lower gravities. However, that's a theory, and I'm just recalling some other evidence that we've seen, which is even at lower gravities, we have trouble with us flying as we get farther away from the portal. So if we're closer, it works, and if we're farther away, it's behind us.
So is your change velocity command going to affect the amount of available thrust over any given period of time, so that you also give the same command, sort of move to the right using 7 seconds, but it adds less velocity each time, so we get a slowed down version of the simulation?
No, change velocity is going to change velocity instantly without changing thrust.
Right, okay, so we skip over the accumulation and go direct to verifiable, factual speed.
Right, and so the question is, if we type in CV, we're going to work? And if it does, then that's more evidence that this idea that it's related to the acceleration is the problem. That we're accelerating past a point in time and space where now we can no longer catch it. That's kind of the idea. And even if that's the case, I feel like we can still solve this problem in a different way. We can say, oh, we're real close to it, let's drop, if we're close enough. So let's see if we can get that. So I'm going to do change velocity. I'm also going to do one other thing in here, and that is I'm going to get vertical thrust. I'm going to return 0. And, not here, for the drone. Sorry, let's go to the drone and look at the overrides for the thrust, and I'm going to return 0 for that. So we are not going to be able to move our drone. Wait.
Now, if you do that, you won't be able to go down low enough for the.
I'll only do it on horizontal velocity is what I'll do. So get horizontal thrust. That's what I want to do. Every time it drops, it should catch now. Fingers crossed. Wait, Will Bennett says that now? We haven't changed any code yet. Okay, so I'm going to do this right now. Get horizontal thrust to 0, and vertical thrust we'll be able to control. And so now let's do a refresh. Debug. Now, why can't I run? What is going on here? Okay, there we go. All right, so let's run it. All right, let's switch back over to this view right here. Let's inspect it, bring up the console. Let's first test to make sure we can do that. So let's go in and say drone, and we're going to say down 3, and then I'm going to say CV 4,5. Nope. Why isn't CV working? Background worker, CV goes to change drone velocity. That executes change drone velocity. We should be able to set a breakpoint in here. Let's set a breakpoint there and see what happens. Oh, wait, I know why. Hold on. Let's not set a breakpoint. Let's go back over and watch again because I didn't prefix that with a bang symbol. So let's say 3, 4, and there it goes.
There we go. That worked.
Okay. One other problem, though, it's got a kind of a delay thing it slows itself down. So we're going to have to fix that too. But let's go in and say test sample 4, and then let's go change our velocity. And I want to say to the right, I'm going to go 10 meters per second and 0 up or down. And here comes the command.
Well, there's certainly a prediction of possibility, but of course it was then getting slower and slower and slower. So the time increased, which was entirely accurate, and eventually it gave up and decided you're not going to cross here and removed it. So arguably that was very good.
I'm worried about this line of code right here is what I'm worried about here is that we might have queued something up and then removed it later. But if we remove it later, yeah, I'm worried about this because we're not seeing anything drop at all. Let's go ahead and let's do the second part here, and that is the.
So were you expecting the meteor to drop even though you never actually managed to cross?
Yeah, because there was that time where it was like, oh yeah, we could have done it, but again, it was changing. So let's go. We've got our return 0 here. Set a Visual Studio bookmark here, and there's something in here I think called decay, as I recall, which is no. What is it? Let's look at where we are using thrust, because I want to find out the whoops, I thought I saw something back behind us there. Nope, I didn't. It was update time. That's what I was looking at. Okay. All right. Add meteor, update position. Change velocity right here. I think this is the slowdown. I think that's the decay. Let's assume this is. We're going to say constant decay of type number equal to 0.99. And then let's use this. And let's do this for now. Set a bookmark here because we have to change this code as well later. So I think what that's going to do, it'll decay my horizontal. Oh wait, that's the wrong one. I want to do it the other way around. It'll decay my horizontal, and it will change velocity by. Let's double check that. Delta velocity, yeah, it's just multiplying by it is what it's doing right there. So we want a 1 right there, and I think we're good right there. So let's try that. We'll do a refresh and see if how that impacts the drone. I'm going to bring out the drone immediately.
So the decay is effectively a multiplying factor, so your horizontal will not decay?
Right. It'll always be at that velocity. Well, Bennett says, don't worry about it. All right, here we go.
I think that was the previous reference to Mr. Announcerbot things.
All right, here we go. We're going to go right. Change velocity 4,0. And it should never slow down.
And that looks pretty constant. So, yeah. In other words, we will definitely cross the vertical.
At a predictable point, right?
Exactly.
Which is part of what we're trying to, the challenge here.
And at a relatively slow speed, giving plenty of time, in theory, for that meteor to fall.
Now, I just typed in CV00, and now I'm going to go down 3. And I'm going to bring up the test sample with the portal. And now I'm going to type in CV. We're going to go right at 4. And then velocity
I
4.
wonder if 4 is maybe a little high for the distance, but we'll see.
I'll change it to 2. 2 meters per second. I think we're still on planet Earth anyway. Hold on.
True.
Let's launch and verify that. Yeah, that looks like Earth there in the corner, bottom right corner. Yeah, that's Earth. Okay, so here we go. So I'm going over at 2 meters per second. Go. And then it goes away.
So I begin to think you're correct about we're removing things at a time where...
Yeah, where it's not quite ready it's not enough time to drop.
Yeah.
Yeah. So I think let's try getting rid of that line of code for a second and just see how we are doing.
Yeah.
I think this is somewhat problematic right here. Is what I think. There may be something else we have to do here. Let's refresh. Test sample 4. Shoot, too soon. Now I can do it. Pluto, drone. Let's go down 2.5, and then let's type in CV, and then we're going to go right at about 3, 0, and see what happens. I want to see the crosshairs. The crosshairs aren't even there.
Right, but last time we did this particular experiment, we stayed on Earth. So we've changed a few different things at the same time here.
All right, hold on. Yeah, maybe we didn't have enough time to drop to begin with. Let's change it. So let's type in CV. We're going to go right 1, 0.
Although that's interesting.
Oh, I just changed my velocity. Oh, but look at this.
Possibly
Look
because
at
you
this.
started significantly.
Look at this. Look at this.
It's going to hit.
The code is right.
It's possible we have fixed it now. And what happened is in the first instance, you started off sufficiently far right so that it wouldn't work. But in the second instance, you had rebounded off the left-hand side. And therefore, there was enough time for a complete cycle.
No, actually, right? I'm pretty sure it's not it. I'm pretty sure that we haven't fixed it. That the problem was because of the changing. Look at the crossovers, right? The problem is that because it's accelerating, it's changing its speed, and the calculations aren't quite working out. This is crossing over exactly because we're moving at a very fixed speed. Do you see what I'm saying? Our prediction in terms of when we're going to cross is much better now than it was. So that's why the code looked good. Okay, so unfortunately we did not fix it, because if I change this, what's really interesting though is if I combine this with some up motion as well. If I increase the, let's switch to a planet that we have more, that we can drop in less time in. Let's go to Saturn, for example. Okay, so we switched over to Saturn. There's Saturn right there, and in fact, watch this. It'll drop it right there. Boom. Okay, so it crosses it, and that change in that square, it draws the square as soon as it crosses over. So give me a second here. Hold on. Wilbur says, I don't think so. I think the calculation does take acceleration into account, if I recall correctly. Yeah, I don't think it does. It is not. It's just looking only at velocity. Here, I'll show you that code so we can look at that right now. It's over in drone, and it's, I think near the end of it, get future point, we get our velocity. And then we just take our we basically, where's our seconds to crossover is meters to crossover. We figure out how many meters to crossover divided by our velocity. There's no calculation of acceleration or deceleration here, because we don't really, I didn't want to bring that in because it was a hard calculation to bring in. Because
so how often do we replace the future point out on our journey towards the vertical crossing?
Well, there's no set time. We're doing this frequently, I guess is the answer. Like every time we do a loop to draw, we're checking.
So halfway to our point, at the very start of our journey, we'll have a very inaccurate statement of prediction, because we are not moving anywhere like the speed we will be towards the end of our journey. Okay, so it'll be very inaccurate. By the time we get halfway, we will be much closer to an accurate statement. And I guess it depends on what is the difference in velocity between the point at which the meteor is released versus when we cross over, and how big is that variance?
Oh, wait. Hold on. We are actually getting our thrust and including it in the get future point.
Okay.
What's interesting is I think I don't want to do this. Is what I think I would want to do. There seems to be is there a max velocity that we peak out at? I'm wondering. I think I want to. Oh wait. Get final velocity. No, this is what's going on here. Is this is just strictly this thrust is being used to calculate the final velocity at the time of the moment right now. So it's what thrust has been applied up to till this time is what's happening here. Get final velocity is here, and it's equal to initial velocity plus acceleration times time, okay, which is just standard physics. Yeah. What did I do? Went to the wrong file. Okay. But then once we have that velocity, we then use that to predict what time it will be. And it's the seconds to crossover that's wrong. This is the piece that's wrong right here, because as we're accelerating, we get to this. I think this thing that's happening, this kind of, we're missing that kind of what you call that sweet spot we were talking about, Rory. I think we're missing it. Maybe you need to use get drop time, which is really time to cover distance under constant acceleration. I kind of see your point on that. But the problem is, here's the problem. The problem is we don't know what that, the thrust is really based on the right thrust time, off time, and the left thrust off time. We don't really know when this code becomes a lot more complex. This code becomes a lot more complex in here. That's me, by the way, hitting that. I just realized I'm hitting the button off the side of my Stream Deck because I moved it near the keyboard. The problem is the code becomes way more complex because we have to check the right thrust time, off time, and the left thrust off time to get a sense of what the thrust is going to be and how long the thrust is going to apply to get there. But I think that's the fix, is the problem. I mean, I'm sorry, it's not the problem. That's the explanation here, is that we kind of have to do that. The problem is that could also change while we're moving, right? We've ultimately are getting a prediction that's coming out there in the future. But the thing that's really interesting is if we have constant acceleration, we're good. The other possibility on this is that our calculations for velocity are wrong when there's, for example, a thrust inside, one of the thrusters is on. That feels like pretty true to me. Since vertical thrust is still working, let's try another test with this. So let's come out here and let's do a combination. Let's go back to Pluto. And let's this time go up. I'm going to go up for about 2 seconds. And move this guy down. And let's toss that out of the way. And now what I want to do, let's go, I don't think I can go left at all, right? I don't have any control there. So I'm going to go, looks like I want to do a CV, and let's go -1, 0, and then a CV 0, 0 to stop when I get in the right spot. And right about there. And let's do CV -1 to go up. Get up about right up here. Let's make it -3 to go a little faster. Oh, I see. I'm slowing down. Okay, cool. So now what I want to do here is I want to set my right velocity at 1 meter per second. And I'm going to do that. And then I'm going to follow that up with a down for about 2 seconds, I think.
Okay.
Or maybe a down for, the problem is if whatever my down is, I'm not close enough to this, I think, to do this. Let's try it. We'll try a down for 2 seconds, and then we'll set that velocity. So we've got a diagonal going here. Okay, so
except you're down at, it decays enough. Ooh, yeah.
So there. Now look at the second one. Is the second one going to get that? The second one is going to get that. So the second one, so what's happening is that it's our horizontal velocity that seems to be wildly off. Our horizontal calculation is off, whereas our vertical calculation is not bad. It seems like it's pretty good. Let's try undoing some of the work we have and looking at the problem again. Let's go find those bookmarks that we've got here. Let's get rid of that. And get rid of this. So we've got a decay on both sides here. Let's do that. Let's refresh. Maybe add another text at the crosshair to display seconds crossover so we can see how much it is off by. Yeah, I like that as well. Let's consider that for sure. Okay, so we're going to say launch. And we're going to say Pluto. And we're going to say test sample 4. And there's the portal. We're going to drop out our drone. Oh, we got a problem. Decay.
Okay. Decay not defined. Well, yeah. Oops.
Okay. Somehow I did that. All right, so let's clear that. Okay, so we'll do another refresh. Waiting for the load. There's the load. There's the launch. There's Pluto. Here comes the drone. And let's go down 3. And let's go right by 5 or 6. Yeah, so there's the drop. And it drops and doesn't update or fix it since. And let's look at our at what we've got over here. So we had an arrival time of a drop time of about 6 seconds or whatever seconds of crossover. So here we can kind of see the data here. Let's switch so we're full on console here. So here we go. Look at it. Look at what happens. Seconds to crossover. We're at huge numbers as we are starting to accelerate, right? Then we get to. Here's not enough time to drop. Right here is where we get not enough time to drop. So we got seconds to crossover, drop time in seconds, not enough time to drop. Before that, we had seconds to crossover, drop time is 6.99 seconds.
So 0.02.
And we pushed the
variance.
meteor. We pushed the meteor on there. We did.
Yeah.
That meteor feels to me like it should have, because we don't call push meteor any other time after that. That meteor should have dropped there. Oh, it did drop there, though, didn't it? And it missed us. Is that right? Because here we say it's 6, but then, the other piece we need is the time of this so we can see from we can see what the deltas are in this to see what's happening, right? Because, wait. Here's how we can tell the time, I think. The drop time, can we tell that? No.
See, by that stage, the meters to crossover is increasing.
Yeah, what I'm looking for is kind of the effects
we crossed over the vertical and just bypass, and then we started returning again.
I'm looking for the effects of acceleration is what I'm doing here, right? In other words, the change between here and here is 5/100ths of a second, right? Do you see that?
So if you had the acceleration, you could tell was it increasing, decreasing, that kind of thing.
If I knew the time between this one and the time between that one, is that something by chance that's in here as well? Doesn't seem like it is here. There's no time of the message. Then I can see I can see what's happening here. Yeah. So I think that's what's happening is our seconds to crossover is dropping because we're still accelerating. And that's what I think. I think the other way of looking at this is if we put the portal further off to the right and we move over here, we have a better chance of hitting it because we get up to speed and then still in time before we can catch it. I think that's the other thing that's happening here, and that's why it's not working from so far down below. So let's look at our layout for a second, and let's try that as an experiment. Let's put a second one out here on the far right here, okay? And so we'll have 2 chances to catch it, and maybe put one, just to really illustrate it, put one here too as well.
Now we're going to get 3 times the data at that point. It's coming through the console, yeah?
Yeah, I think you're right. We're going to get a lot of data on there. So I won't really look at the console too much on this one. We'll just kind of see what happens with it. So let's refresh. Here comes test sample 4. Did I do it too soon? I did. seconds crossover is going to decrease anyway because you're getting closer. Right. Well, what I'm looking at, though, is it relatively decreasing at the rate I'm expecting it to. Okay, so here's test sample 4. There we go. We've got all those. Let's go ahead and close this down. Let's drop. We're going to say drop our drone out. Down 3. Now we're on planet Earth right now. So I'm going to say right for 8. And we should see, I think, work on all of these because we're on planet Earth. We have enough time to hit it. That's off. That's off. I think they were all off by the same amount. So I was expecting the other one to have more time to be able to get there. By the way, if I go slowly, no problem. Right?
Yeah.
Not a problem here, so. Okay, so let's start at this level. Let's go left. And let's go right. So now in this case, what's interesting, we'll go right by 8. What's interesting here is I'm starting off slowly. Is it going to be able to catch me here? Misses before, misses.
Very barely, and then
yeah.
That third one looked pretty close.
Did it look closer? That was the hard thing to tell here. Let's go.
I'm going to watch the stream and see if I get a second run at that.
So let's go up now. Let's go up a little higher here. And here we go. Let's go to the right by about 8. Oh, I caught my own right there. Okay. I don't know. What do you think, Roy?
It's an interesting one, isn't it?
Isn't it? I'm
just watching the replay on the stream, and I guess there's a certain variance for error. So as you say, the closer we are to the portals in the vertical sense, the less margin for error that means anything to the effect. Right. So there's still going to be an error, an inaccuracy, but it's so small that it's within the margin for detection of collision, and then we grab what is necessary. But the further we go away, and indeed the less gravity we have, so the more drawn out all of this is, the more those margins increase, and the more we can demonstrate that it's not quite what we want.
Yeah. It's not bad. Like I say, it's not bad for Earth, and it's not bad for, let's throw that out. Let's go right again by 4. That one might have caught if it had not been bouncing off the edge right there. But so there is, it's, I kind of want to, I'll tell you where my inclination is on this. And I'm not proud of this inclination. But I kind of want to solve this problem by fudging.
Okay.
Is what I want to do. I kind of want to come in and hack it. I think what I want to do is I want to look at what the differences are, and kind of fudge it a little bit to change the drop times is kind of what I want to do. But I'm not entirely certain that's the correct course of action. So I think what I'm going to do is I'm going to sit on this and think about it.
Okay.
Is what I think I'm going to do. And we'll, I think, give away a copy of CodeRushed like we do every time. And
always a good thing.
Unless you've got thoughts on how you want to solve this. Maybe you update the meteor drop cross time until it drops. Until it drops. I think we're effectively doing that as well, Will. And that's over in Portal, where we call queue the meteor. If we queue the meteor with a new drop time, that QMeteor call calls remove meteor to remove any existing one. So it effectively updates it. So the idea is that we keep updating until we're, have you tried get diff margin yet? I have not done that yet. Let's look at that for now.
That's a new one on me.
This is the one, highly rated. Let's do it. Where am I putting this?
Somewhere temporary.
I'm going to put it in my downloads is what I'm going to do. All right, saving that. Okay. So I will install that today, Will. Let's give away a copy of CodeRush, and we'll come at this tomorrow and with the intention of starting this. By the way, next Tuesday, Rory, I won't be able to make it. You got a Monday opening by chance? You want to reschedule Monday?
Yeah, that's a possibility. Yeah.
Oh, Will Bennett says
good.
you should be able to install it from VS. That is, I've not tried doing that. Yeah, I think he's absolutely right. So tools, extensions, and updates.
Do you know, I think there's somebody who's maybe proven that they really do deserve a copy of CodeRush that we should totally give one away to.
Who?
This chap I know desperately in need of a copy. He's called Mark Miller. And I think, he's put some sterling hours in.
Yeah, I need a copy of it. I'll be installing that later today. Margin, like that, and then we can just grab it from here. Get diff margin, download, and it's putting and installing it. Cool. Okay, cool. Yeah, so I can't get CodeRush delayed. I have to remove and do some tweaking on stuff to get CodeRush back here. So let's give away a copy of CodeRush. Speaking of which, let's do that. CodeRush is brought to you by
Express.
And today's winner is
Cryptic Enigma 00.
Cryptic Enigma 00.
Cryptic Enigma.
Congratulations. I will send you chat instructions via chat. We are here Thursday. We're here Wednesday, but next week we're going to be here Monday. Right, Roy? Are we tentatively doing that? So we'll do a show
I reckon
Monday.
we can do that.
Monday, Wednesday, and Thursday of next week is what we'll do. So that's it. I want to say thanks to everyone. Kind of an interesting show, Rory. It was like this.
Yeah.
It's a problem that involves greater brain power than I think I'm bringing to the table right now. I'm going to have to get serious about this if I'm going to really solve this.
Yeah. Well, I'm sure we'll get there.
We're sure we'll get there. That's that positive British attitude that I love. All right.
Oh, yes.
We'll do
absolutely.
it. All right. Talk to you later. See you guys on Wednesday, tomorrow. Oh, and guess what? I don't have my ending button hooked up.
Oh,
That was one of the ones I lost.
Do, 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 do,
I know. It's going to take hold on a second. We're going to go in here and we'll, because we lost that, let's switch over to my right deck over here. Wrapping up. There's my ending. Let's go find it. Where is it? Where is it? Ending. So it's not anything that starts with Guy. CodeRushed ending. There it is right there. Here we go.